All right, so we've been talking about crystal lattice structures and unit cells. And the question is, how do we know all this information about unit cells and crystal lattice structures? Well, the short answer is through X-ray diffraction. X-ray diffraction is a technique where we can shoot X-rays at solids, and based on how the X-rays bounce off them, we can tell a whole lot about their structure at the atomic level. So we can do this using a mathematical equation called Bragg's law. So I'm going to talk about that mathematical equation in just a few moments. Let me show you two kind of planes, two layers of a solid. So these two lines here represent two layers of a crystal. Now, I'm going to draw some atoms in the crystal. Let's say I have atoms here and here. And again, these are two layers in a crystal, and these are kind of atoms in the structure. So the question is, how do we know how far these atoms are from each other? How do we know what the unit cell looks like? Well, in X-ray diffraction, we shoot X-rays at the solid. Okay, so here is my X-ray coming in. Now, when an X-ray comes in, if it's empty space, it's going to pass right through. But if the X-ray hits a particle, it is going to bounce off. And if you remember from physics, the angle of incidence, we're going to call it theta, is equal to the angle of reflection. Okay, so since they're equal, I'm going to call them both theta. Now, this is going to be true. So if I go through empty space, I'm just going to go pretty much straight through until I hit a particle. Boom. Okay, so there I'm going to have some angle of incidence, and once again I'm going to have reflection, and the X-ray is going to be kind of bounced off. Okay, so the angle of incidence equals the angle of reflection. Now, these X-rays will go towards a detector, okay? And when they hit a detector, only the wavelengths that are in phase will be detected. So then you can use Bragg's law to figure out the distance between the atoms. So Bragg's law is written as n times the wavelength lambda equals 2d sine theta. Now, what is d? Let me get a different color here. D is going to be the distance between these atoms, D. It's also known as interplanar spacing, so the difference between the planes of the crystal. So D, or the interplanar spacing, is measured in units of length because it's just the amount of length between the layers of the crystal. And of course, it's going to be in very small units since we are dealing with the atomic level here. N is the order of diffraction. Okay, diffraction order, this is usually given to you as an instrumental thing, so that's not something that you're generally asked to calculate. The wavelength is the wavelength of the incoming X-rays. So this is the wavelength of the X-rays. X-rays are a high energy, short wave form of radiation. The theta here is the angle of incidence, which is also equal to the angle of reflection. So this can be picked up by your detector. Now, what we can do is use this equation essentially to determine the interplanar spacing, the distance between the atoms in the crystal. So let's do an example where we use Bragg's law. A silicon crystal has interplanar spacing of 313 picometers. Pico is 10 to the minus 12. What is the angle of first order diffraction of X-rays that have a wavelength of 154 picometers? So this is a problem where we have to rearrange and use Bragg's law to figure out the variable that we want. Okay, so you should, I'm just giving you an example here, but you should be able to solve for any variable that's in Bragg's law. All right, Bragg's law is n lambda equals 2d sine theta. Now, what we want to do here is solve for the angle of first order diffraction. And the angle of first order diffraction is theta. So we want to rearrange this equation to solve for theta. I'm going to leave theta underneath the sign and say that n lambda over 2d is equal to the sine of theta. Now we can plug in our variables. The problem told me that we're talking about first order diffraction, and that's the way they're telling me that n equals 1. So I think I know all of the variables here that I need to use. N is 1. Lambda is 154 picometers. And I'm putting that over 2 times d. 2 times d, the d was 313 picometers. And that's all going to be equal to the sine of theta. So simplifying on the left, that becomes 0.246 is equal to the sine of theta. So if I want to solve for theta, that's going to be the inverse sine of 0.246. Now, if you plug this into your calculator, depending on whether your calculator is set in radians or angles, you might get 2 different answers. So make sure you know what your calculator is set in. On my calculator, I get 0.249 because my calculator is set in radians. To convert from radians to an angle, you can say 0.249 radians, of course, times 180 over pi. And that is going to give you an angle of about 14.2 degrees. So this would be the angle of first order diffraction of X-rays with lambda equal to 154 in this silicon crystal. All right, so make sure that you check the angle radian settings on your calculator when you're doing these problems so you know which unit to report.